Hello, everybody. I'm your teacher, Iris. I am going to explain you how to do the balancing chemical equation. This was Guardia from last week. I know a lot of people had some problems doing this. I understand it is not so easy, but I hope with my explanation you will be all able to know if you do it right and to finish if you have not finished. So first thing is to click this. I already have this link here. Okay, so first we explore this, no? So if we click here, we got one molecule of nitrogen. One molecule of nitrogen is composed of two nitrogens, no? That's why we write N2, and here we see two little blue balls. And one molecule of hydrogen composed of two hydrogen, two little white balls, no? And if we create one molecule of ammonia, we see one nitrogen and three little hydrogen balls, no? So this is not correctly balanced. How do we balance this? You see, if you balance, you get a smiley face. And you get these arrows in yellow. How have I done it? So I start with two nitrogens because each time I put one molecule, then I have two nitrogen atoms. Then I need to have two nitrogen atoms at the end. That's why I put here a 2. Then 2 times 3, I have 1, 2, 3, 4, 5, 6. 6 hydrogens. In order to have 6 hydrogen, I need to have 3 molecules of hydrogen 2. Okay? So, to answer this, you need to say the simulation indicates that a equation is balanced with a smiley face, for example. Okay? And now we are going to count the number of molecules. Okay? The number of molecules here we have 1, 2, 3, 4 molecules. Okay? And here how many molecules? Only 2. 1 and 2. Let's do the separation of water. We start with one molecule of water. This is going to give us one molecule of hydrogen. But if you see here, you have 2 red and here 1. So you need to have 2 waters. And in order for the amount of hydrogens to be the same, you need 2 hydrogen molecules. So you start with 2 water molecules, and at the end you have 3 molecules, 2 of hydrogen and 1 of oxygen. Okay? Let's look at the atoms. So we can do this and this at the same time. How many atoms? 1, 2, 3, 4, 5, 6 atoms, no? And here 1, 2, 3, 4, 5, 6 atoms. The atoms need to always be the same. Yes? With ammonia we have 1, 2, 3, 4, 5, 6, 7, 8. Y aquí 4 plus 4, 8. Yes? Molecules, as we see, are not the same number of molecules before and after the reaction, but atoms are always the same. Okay? Let's do methane. So we start always with 1 because 0 makes nothing, no? And now we have 1 carbon atom, so let's do this. And water. Is this okay? Not really, because I have here 4 hydrogens and here I only have 2. So now I have the same amount of hydrogens I need, but how many oxygen? I have here 2 and I have here 1, 2, 3, 4. So now it's done, no? How many molecules? 1, 2, 3. And here 1, 2, 3. They can be the same number of molecules, but they don't need to be, no? And how many atoms? 5, 7, 9, and here 3, and 3, 6, and 3, 9. So, same number of atoms. Always same number of atoms. So, is the number of molecules on the left side of a valence equation always equal to the number of total molecules on the right side? No. It doesn't necessarily it is not necessarily need to be equal, or whatever you want to write. No? And the number of atoms? Yes. It's always the same if the reaction is well balanced. ¿Sí? Si no es el mismo, está equivocado. So, what is the same on the left and right side of atom? Of a balance equation? The number of atoms needs to be the same. Yes? Okay. Now, if we look this, we have always integers, which is mean. Solo podemos poner aquí números enteros. ¿Vale? Why? Because I cannot have a half of a water molecule. The molecules are a arrangement of atoms that it is always the same, so I cannot have a quarter of a molecule or 3/4 of a molecule. I can only have 1, 2, 3, okay? Solo números enteros. So, this is why. Because the number expresses the amount of molecules and we cannot cut the molecules. Okay? So what can we use? All of them. All of the yes, all of the integers. Yes. So if we have O2, like here, for example, what can I put here? I can put nothing. Nothing is always 1. Okay. I can put 3 and 6. I cannot put 3O because taking away this number will make it another molecule. And I cannot put O3 because if I put here 3, there will be another different molecule. Okay? So, only having always the same molecule, O2, the subindex, el subíndice, we can never change it. Okay? We can never change this small number. We can only change the stoichiometric coefficient, the number, big number before. Okay? Never the small number. So, number 8. We have these two reactions. Okay? The first one I see 2 SNO2 plus 4 hydrogen 2 give us 2 tin plus 4 water. Okay? And the second I have 1 tin oxide plus 2 hydrogen to give us 1 tin plus 2 water. Okay? They say both are correct, but so both are well balanced, but the correct way is the second. So what happened between the first and the second? We have divided every coefficient by 2. 2 entre 2, 1. 4 entre 2, 2. 2 entre 2, 1. 4 entre 2, 2. Okay? If you remember this chemical equation, they work as a mathematical equation. If you can divide everything by the same number, the equation remains the same. Okay? So, But can we divide this equation by another number and have them also correct? No. We can only divide by 1, which is leaving it like it is. Why? Because if I divide by 2, here I will have a 1 and here a 1, but here and here I will have 1/2, un medio, see? And we cannot have non-integers in coefficients, okay? So that's why not. In a complete sentence, so I will write it for you. We cannot divide equation EE because in doing so the coefficients will not remain integers, which leads to not complete molecules, and that doesn't have any chemical meaning. Okay, we want this to mean something. If we divide by whatever, it loses the chemical meaning, and we do this in order to have some chemical meaning. Okay. In a complex sentences, ¿por qué no le gusta esto? Okay. Write down a method you could use to determine if an equation is written in the correct way. Okay. First, you need to be sure there is the same amount of atoms in each side of the equation. Next, for that, you cannot use any non-integer coefficient. When you are finished, you need to check if the equation can be simplified. Okay, I hope you understand this, and please, if you have not done this, I know it was not easy, try to do it and try to send it to me this week. Okay, bye.